Engineer Javaid Iqbal is an accomplished professional engineer with 24 years of diversified experience with KESC, Siemens, Linde, Pakistan, and since last 14 years, he has been working with multinational engineering consultancy company OMS. Engineer Javaid Iqbal had core expertise in power system studies, planning, power project design and engineering, construction management, and assets management of high voltage grid stations, GIS and AIS and transmission lines. Thank you. I would like and request Engineer Javaid Iqbal to proceed.
Bismillahirrahmanirrahim. Assalamu alaikum. First of all, thanks to our honorable guests and the participants for hearing me. A short introduction. I belong to OMS Private Limited. This is a consultancy firm which provides its consultancy services over a broad portfolio of power sector, including the generation, the transmission, and the distribution side. In generation side, we are also diversified from conventional type generation to nowadays the renewable integration and the microgrid, which is the topic for today's discussion point. Similarly, we also provide our services in transmission network ranging from medium voltage, EHT 132 to 2500 kV and so on. And similar is the case with our distribution network. We are also engaged in providing our consultancy services as a part of an operation and maintenance. So this is about a short description of our company. Now coming back to my main topic, that is hybrid microgrid design for high reliability load center. Next slide. Short background description. We all know that the basic elements of a power system is generation, transmission, and distribution. If we go for generation, the concept of utility always remains. The next is the IPP mode, and the last is in generation is the captive mode. If you go for transmission network, it is usually classified with respect to voltage level, that is the medium voltage level and the high voltage level. Next, the third element of the power system is the distribution network. In distribution network, we can classify it into three broader categories. The first one is the residential, the second is the commercial, and the third is the industrial. Kindly keep please. In industrial, there are a broad classification of two types of load. The one is the high reliability load and the second is the medium reliability load. The high reliability load is our today's areas of focus and the key point of discussion. Next. Next, please. When? This is, in this slide we have showed the power supply transition mode. For residential and commercial, starting from the past era, when there is only a utility connection, the need for transition arises when there is a shortfall, when the people face a shortfall of demand and supply and the load shedding issues. Initially, the people have adopted backup power source for their use, that is standby generators. But with the passage of time and the rising cost of the fuel, the high per unit cost moved them to adoption of renewable generation, that is the solar, and later on due to some net metering policies amendment in the recent era, the consumers are now shifted into hybrid solar generation mode, which keeps them the less reliance on the utility sector and also save their cost. So the primary driver for a residential and commercial consumer is the cost, which leads to such a transition. And beside this transition, the renewable generation, as you all know, that has less carbon footprint as compared to the conventional generation. Now the industrial, the key focus area. Although the primary driver is here also is the cost, but the issues are the same, that they have less reliance, the high per unit cost and so on. They all also adopted the solar and the renewable type mixed energy generation concept, the hybrid one, but still the issues persist. And what are the issues? Kindly move to next slide. Because they have the primary driver constraint of the cost, which is the cost of doing the business nowadays for industrial consumer. But the issues, the technical hidden issues are voltage instability, poor power factor penalties, intermittency of solar and wind, and the curtailment of losses. The voltage stability, as you all know, that the solar and the wind has certain non-availability period, or there are certain factors when the load suddenly drops into the system, so which also creates a frequency and the voltage instability issues into the system. As you all know that the renewable energy has very limited or no, you can say, the power factor provision. So the power factor is also low and you have to adopt certain measures to overcome these issues. The intermittency of solar and wind, as we all know that solar is available during the peak time. During night time it is not available, and similar is the case of the weather conditions. When there is a cloudy weather, it is also not available. The wind also is restricted certain times with the speed or the wind velocity that is available, which cannot be predicted and cannot be constant. The curtailment losses are such that, for example, when there are renewable generation, there are times of low load demand. So there are certain curtailment losses that the utility has to adopt in this. So as shown in this slide, the cost of no generation, the cost of low consumption, and cost of maximum generation. The cost of maximum generation is when you adopt the renewable energy alongside with the other means of power source, so which also lead to the cost of the operation and maintenance. But when there is a low consumption, that the cost of O&M and loss of possible units that could have been consumed otherwise but not due to restricted mode. And similar is the mode as when you are running in a grid tied mode and due to non-availability of grid, although you have the renewable generation facility, but it cannot be utilized. Next slide. Next slide. I think one is missed. So up till now, what are the key takeaways? That cost reduction drives residential and commercial adoption, but industrial renewable generation integration is primarily governed by reliability, resilience, and operational continuity. So these are the key takeaways up till the now. Next, please. Here now I am describing you a case study which we have performed for some of our foreign projects. We also provide our consultancy services outside Pakistan as well. It's a case of hybrid renewable load center challenge. What happens that high reliability load center integrates the grid tied solar and wind generation to reduce dependence on the grid and lower energy per cost unit. However, due to its intermittency nature, the renewable system experiences several challenges. These include persistent power factor issues, voltage instability, and renewable energy curtailment losses. In extreme cases, unexpectedly, utility outages lead to total blackouts, causing significant economic losses, downtime, the production losses, and reliability issues. Next. Here we have simulated a case study. In normal mode, you see here that we have a generating unit, a grid tied system, a solar PV system, and the renewable generation system. Here we have created a fault reflecting any type of fault in a power system causing the grid outage. Once the grid has gone outage, since due to there are no sync, or you can say the reference voltage available to remain the system intact, ultimately leading the generator, the solar system, the WTG out of sync, so no reference voltage available, the entire system goes into blackout, and the critical and the non-critical loads are affected, hence causing a, you can say, a production loss or an economic loss for an industry, which usually industry avoid. Next slide, please. So the key takeaway here is that in high reliability load centers, renewable integration must be driven by system resilience and availability with low power unit energy cost, treated as a beneficial byproduct through controllable architecture. Next. So after setting up this criteria, what we have to achieve? What is the ultimate target? Although this ultimate target is for everyone, not only restricted to industries, but for industries this matters a lot, which is the zero downtime. The industries try as best as possible that there should be ideally a zero downtime to avoid any such type of financial and economic losses for them. The key, what we have achieved is that the black start option, the real-time control, the inertia support, power factor improvement, solar and wind firming, genset management, and the load arbitrage. Black start option can also be achieved through auxiliary generators. The inertial support can also be achieved through large turbines. SVG and capacitor banks are utilized for power factor improvement. Energy management system is used for solar and wind firming, and the synchronous controllers are used for genset management system. Similarly, for load arbitrage system is also achieved through a controlled energy management system. Next. Here we have also simulated a system. You can see that here is a generator similar as our previous one, the solar, the WTG, the wind, and the grid system, all on a reference bus. But what do you think? Is this a microgrid system? No, this is not a microgrid system, because it lets a control architecture system which overall governs the system. Kindly click for having some further simulation.
So you have 5 minutes.
Yes. Now here is stay. Now here is the microgrid control architecture system, you can see, which will govern the overall system, and in case of any outage from grid or instability issues, it will perform as per its algorithm. Next slide. Here are the modes of the microgrid system. There are two modes of microgrid system. One is the grid following, and the second is the grid forming mode. The grid following mode usually runs on droop control mode, while the grid forming mode runs on VSG mode, which is the virtual synchronous generator mode. Next. Droop control. What is droop control? Just like in typical conventional system, here the concept of droop control is almost the same. It injects, for example, it provides support, power type support. Means whenever there is a requirement of active power, it controls frequency via droop. Second, when there is a requirement of a reactive power, it controls voltage via a droop. Next is the PID control. In a grid following droop control system, the PID controls on the difference between a reference set point from root characteristics and the measured grid parameters. Below we show a block diagram which elaborates the droop control mode, the renewable generating units, and the power measurements. And from the load side, there is also a power measurements, which is treated as a reference active and the reactive powers, and the generating unit notated as PGen and QG.
So the system or the algorithm calculates the difference between the two. Whenever there is a difference occurred, it will be reflected or treated as an error between the reference load and the measured generated values. So this can be overcome nowadays through a storage system, usually BESS or control architecture through a control architecture system. And when this difference, or you can say the error, becomes zero, the system runs in the normal mode. Next slide. Now the virtual synchronous generator mode. In virtual synchronous generator mode, the control system mimics the mechanical dynamics of a traditional synchronous machine. Here BESS acts as the energy reservoir required to provide the rapid power injections or subtractions controlled through fast computational controller. The basic concept here runs on the main power swing equation, which has two parts. The one is the synthetic inertia control and the second is the droop control mode. In synthetic inertia control mode, there is a limitation that it is very fast and provides a certain backup for few milliseconds. After that, the system moves on for normalizing the voltage stability of the system through droop control mode. Overall, this is achieved through a battery energy storage system, or you can say the ratio between these two is usually you can say the inertial support and the droop control mode. Normally a balanced system usually runs on 25 to 25%, 75% ratio. Now, what is the virtual synchronous generator? The virtual synchronous generator provides active power support, the inertial support, which you can say that what is this? Whenever there is a fault or the system, for example, the grid goes out from the system due to some reason and you are running in the grid following mode. So what happens? The controller slows down the rate of change of frequency, which is normally termed as rock off, as you all know. During this period, the reactive power stabilizes the voltage transient and the target is to reach the nadir point. The nadir point is the point where the rate of change of frequency becomes zero. After that, the droop mode injects the voltage or the active power supply and the necessary reactive power to stabilize the system back to its normal condition. So the duration of the inertial support is very short duration, but is high power delivery. During this short duration, focus mainly on the transient stability and the recovery of the system.
So request to conclude, please. Request to conclude in 2 minutes, please.
Oh, okay. The time is very short. The topic is large. No problem. Now let's move to the next slide. That what will happen when a three-phase. I think move to next slide. So what happens now when there is the availability of a microgrid controller system? The similar fault occurs, in the system, causing the grid system to go on outage. Ultimately, the genset will also go on outage. The system WTG will also go on outage, and the non-critical load leading to, so it will not be served immediately. The prime theme for industries is that during that period you have to provide a backup to critical loads which will run their process of prime importance. One thing here is I want to mention that this is not necessary that you can provide the support from BESS for critical loads. It can also provide support to non-critical loads, but for that you have to scale the BESS system on a larger scale, which ultimately reflects in high cost. So in order to restrict the mode to financially economical one, so the BESS sizing is done in such a manner that the load are classified as a critical and the non-critical load. Now next. So here we have shown some phenomena that how this occurs and the initial droop mode after a certain time period. The inertial support, we have shown the inertial support through the blue color of the base in this slide, and the droop mode support through these green color modes. The ratio, as I have already explained, is 25 to 75 ratio. These are. So now I will conclude. Although cost is a key concern of most consumers as it drives decisions, industries that prioritize in operational continuity and precise control can achieve zero downtime, ultimately leading to substantial economical and financial gains. So these are the key parameters for, once again, in the conclusion slide, that the primary driver, although for every type of consumers, is the cost, but for industry there are certain critical technical issues which I have explained up to a certain extent in my previous slides, and leading them to adopt to a control architecture system, which nowadays is a microgrid controller system, and the key element is the control architecture and the proper battery based energy support system. Thanks for watching.
Thank you, Engineer Javaid Iqbal, for that comprehensive presentation. Our next and final speaker is Mr. Lu Hui, CEO Badar Energy China, which is connected online.
हेलो जी, जावेद साहब आपकी प्रेजेंटेशन जी, जावेद साहब आपकी प्रेजेंटेशन बहुत ही हाईली टेक्निकल थी, वेरी गुड. मे बी एज अ लेमैन आई वुड नॉट बी एबल टू अंडरस्टैंड ऑल ऑफ इट. मुझे ये पूछना है कि आप ये प्रपोज कर रहे हैं कि माइक्रोग्रिड के ऊपर हमारी एग्जिस्टिंग ग्रिड्स को कैसे ट्रांसफर करना है? दैट इज व्हाट यू आर प्रपोजिंग?
असल में बिल्कुल.
आई डिड नॉट गेट द आइडिया व्हाट एग्जैक्टली योर प्रपोजल वाज.
एक्चुअली देखें, हमारा जो मेन थीम था इसका वो ये है कि माइक्रोग्रिड की इंटीग्रेशन की एडवांसमेंट हो जाए इंडस्ट्रियल स्टेज के ऊपर, जो कि शुरू हो चुकी है पाकिस्तान के अंदर. हमने पाकिस्तान में भी मल्टीपल प्रोजेक्ट्स, अभी हमारे कुछ कंप्लीट भी हो गए हैं एज अ कंसल्टेंसी पार्ट के ऊपर, ठीक है. इसी तरीके से अब्रॉड में भी, अब्रॉड में तो खैर चल ही रहा है, काफ़ी पहले से चल रहा है, कुछ टाइम पहले से, लेकिन पाकिस्तान के अंदर विद इन एन एरा ऑफ, यू कैन से, लास्ट 2 to 3 ईयर से ये सिलसिला अब शुरू हो चुका है ट्रांजिशन का. तो ये हमारी मेन प्रोजेक्शन है ना. इससे क्या होगा कि एक तो आपकी जो ग्रिड स्टेशंस के ऊपर यानी यूटिलिटी बेस्ड जो सिस्टम है उसके ऊपर आपकी रिलायंस कम हो जाएगी, ठीक है. सिस्टम में स्टेबिलिटी भी आ जाएगी आपकी काफ़ी हद तक, ठीक है ना. तो ये मेन थीम जो है ना वो ये है बेसिकली इसके अंदर जो है ना. और ऑब्वियसली आपकी कॉस्ट जो है वो एक काफ़ी हद तक मिक्स एनर्जी की फॉर्म के अंदर एक आप समझ लें कि चीपर हो जाएगी कंपैरेटिवली जो हाई टैरिफ कॉस्ट का जो आजकल इशू बना हुआ है तमाम सेक्टर्स में है. ऑब्वियसली वो सिर्फ इंडस्ट्रियल के लिए नहीं है, इंडस्ट्री पे ज़रा ब्रॉड स्पेक्ट्रम हो जाता है और बाकी रेसिडेंशियल और कमर्शियल पे भी है.
अच्छा, एक और सवाल ये है कि डेटा सेंटर्स जो कि पाकिस्तान में अब थोड़ा बूम आ रहा है उसका,
जी जी जी,
up to 24-25 there were around 15 data centers, now there are 30 data centers, and what is happening in the Middle East,
जी जी,
data center locations would be shifted to Pakistan as the main hub. That is what I see.
जी.
Sir,
What
short
do you
answer.
do? Yes sir, what do you do for the critical infrastructure having the microgrid solutions?
मतलब विद रिस्पेक्ट टू आप डेटा सेंटर्स के हवाले से स्पेशली बात कर रहे हैं जी. इसमें थोड़ा सा मैं राइट नो नाम तो मैं डिस्क्लोज़ नहीं कर सकता. हम करेंटली पाकिस्तान में ही तकरीबन ओवरऑल पाकिस्तान के अंदर एक तो कराची बेस्ड ही है, इसके अलावा 2 और प्रोजेक्ट्स हम कर रहे हैं दैट आर रिलेटेड टू डेटा सेंटर्स ना. तो वहाँ पे इसी किस्म की इंटीग्रेशन चल रही है, ठीक है ना. हमारी जो बेसिकल मेन थीम है वो कंसल्टेंसी सर्विसेज है. आपको पता है कि पाकिस्तान के अंदर राइट नाउ हम उस ट्रांजिशन फेज़ के अंदर है कि इस वक्त हमारे पास मोस्टली जो एल्गोरिथम्स हैं वो बेसिकली चाइनीज़ बेस्ड हैं, ठीक है ना. तो वो इन कोलैबोरेशन विद सर्टेन EPCs आप समझ लें कि कुछ फर्म्स के साथ वो चल रहा है सिलसिला. बट वी आर वेरी होपफुल कि इन अ शॉर्टेस्ट स्पैन ऑफ टाइम, क्योंकि गवर्नमेंट भी कुछ इंसेंटिव्स इसके अंदर प्रोवाइड कर रही है, ठीक है. और जैसा कि आज के सेशन के इनॉग्रल सेशन में भी सर ने भी फरमाया कि ये एक बहुत इंपॉर्टेंट चीज़ है कि पाकिस्तान उस ट्रांजिशन फेज़ में अपनी यंग टेक्नोलॉजी, यंग यूथ को स्पेशली उस हिसाब से ट्रेंड करे बेसिकली ना. तो ये चीज़ें काफ़ी अच्छी चल रही हैं डिफरेंट सेक्टर्स के ऊपर, एंड वी आर होपफुल कि अगर गवर्नमेंट की सपोर्ट रही तो विद इन अ वेरी शॉर्ट स्पैन ऑफ टाइम पाकिस्तान इस कैपेबिलिटी में भी काफ़ी हद तक आगे निकल जाएगा ना.
Thank you, sir. Thank you very much.
Last question, please.
जी प्लीज़.
Khalid Mazhar from Siyasan Energy Solution. Sir, my question is that कि जिस तरह आपने इसमें बताया कि ग्रिड के फेलियर की कंडीशन में वर्चुअल सिंक्रोनस जनरेटर बेसिकली बेस्ट प्रोवाइड करेगा.
जी.
इट मीन कि वो एक हमें रेफरेंस वोल्टेज देगा उस कंडीशन पे।
जी
तो इफ माय सिस्टम इज अराउंड 10 मेगावाट,
हाँ
देन हाउ मच इज द साइज ऑफ बेस?
सर, जैसे मैंने एक छोटा सा कॉन्सेप्ट यहाँ पे देने की कोशिश की है कि आइडियली अगर आप देखें कि मैं जो आपकी बात समझाऊं कि आपका 10 मेगावाट का लोड है, ऐसे ही है,
एग्जैक्टली।
ठीक है ना? तो आइडियल कंडीशन तो ये होनी चाहिए कि आपका 10 मेगावाट ही का लोड सर्व कर सके बेस्ट, ठीक है ना, मतलब ड्यूरिंग दैट ट्रांजिशन पीरियड के ऊपर, ठीक है। तो 10 मेगावाट को सर्व करने के लिए बेस्ट की कैपेबिलिटी 10 मेगावाट से ऊपर ही होगी, पहली चीज़ तो मैं ये क्लियर करूँ, ठीक है। लेकिन क्या है कि बेस्ट
Sir,
सिस्टम
it can be discussed at the lunch time. I would request Mr. Adnan Tapal to share his remarks, concluding remarks.
आई विल एक्सप्लेन।